Good day. Welcome to the discussion class on power series and their convergence. Before watching this video, make sure na napanood niyo na yung lecture video on power series. Our goal for today is to find the radius and interval of convergence of the given power series. We have here 10 items to answer, 6 of which are exercises given in page 62 of Math 92 module. Let's start. For number 1, we have the following infinite series. Let's look for the center of this infinite series. To do that, let us distribute exponent n to -1, to 5, and to x. After doing so, we will get the following power series. Let a sub n be equal to this one for all n. Before we apply the ratio test, we have to make sure that each term in this infinite series is non-zero. However, if x is equal to its center, then this infinite series will have terms that is equal to 0. Since that is the case, we exclude the center before applying the ratio test. So for all x that is different from the center, we take the limit of the absolute value of a sub n plus 1 over a sub n as n goes to positive infinity. Replacing values for a sub n plus 1 and a sub n, we'll get the following. The absolute value of -1 raised to n plus 1 is just 1, as well as -1 raised to n. 5 raised to n plus 1 over 5 raised to n is 5, and the absolute value of that is 5. X raised to n plus 1 over x raised to n is just x, so we are left with the absolute value of x. So this is just the limit of 5 times absolute value of x as n goes to positive infinity. Thus, this limit is just 5 times absolute value of x. By the ratio test, this infinite series converges absolutely when this value is strictly less than 1. That is, if you divide this both sides by 5, you'll get the absolute value of x is less than 1/5. That is equivalent to saying that this infinite series converges absolutely whenever x is greater than -1/5 but less than 1/5. By ratio test also, this infinite series diverges whenever x is less than -1/5 or x is greater than 1/5. Thus, so far, we have the following information. From this line, we can say that the radius of convergence of this power series is 1/5. From this line, we say that the possible interval of convergence of our power series are given as -1/5 to 1/5, including -1/5 and 1/5, -1/5, 1/5, including -1/5 but not 1/5, o kaya naman -1/5 to 1/5 but not including -1/5 and 1/5, o kaya naman -1/5, 1/5, not including -1/5 but including 1/5. So these are the information that we can deduce so far. We have here the radius of convergence and the possible interval of convergence. For us to determine kung ano ba dito yung interval of convergence natin, let us check for the convergence when x is equal to negative 1/5 and when x is 1/5. If x is equal to negative 1/5, this infinite series is just equal to this infinite series. Recall that whenever we have this infinite series, where c is a real number, this infinite series converges only when c is equal to 0. Since 1 is not equal to 0, we say that this infinite series diverges. Thus, negative 1/5 is not included in the interval of convergence. So, tatanggalin na natin itong possibility na ito, pati na rin dito. Now, if x is equal to 1/5, this infinite series is just equal to this infinite series. Let's call each term here as b sub n. Now notice that the limit of b sub n as n goes to positive infinity does not exist. Therefore, by the divergence test, this infinite series diverges. Thus, 1/5 is not included in the interval of convergence. So, tatanggalin na natin yung possibility na ito. Thus, our radius of convergence is 1/5 and our interval of convergence is this interval. And this is our answer for number 1. For number 2, we have the following. As you can see, the center of this power series is 2. Let us call each term in this infinite series to be a sub n. Now, before applying the ratio test, we have to make sure that each term in this infinite series is non-zero. That is, we only consider values of x that is different from the center. For all x that is different from the center, we take the limit of the absolute value of a sub n plus 1 over a sub n as n goes to positive infinity. As you replace values for a sub n plus 1 and a sub n, you get the following. So this is your a sub n plus 1, and this is the reciprocal of a sub n. X minus 2 raised to n will cancel out from the numerator and the denominator. What will be left is the absolute value of x minus 2. Since that is independent of n, you can factor that out. And what will be left to you is the limit of 2n minus 1 over 2n plus 1. We know that this limit is just 1. So this limit over here is just the absolute value of x minus 2. By the ratio test, this infinite series converges absolutely whenever this value is strictly less than 1. It is equivalent to say that this infinite series converges absolutely whenever x is greater than 1 but less than 3. By ratio test also, we can say that this infinite series diverges whenever x is less than 1 or x is greater than 3. So far, ano ba yung information na meron tayo? From this line, we can say that the radius of convergence is equal to 1. And from this line, we say that the possible interval of convergence are 1, 3, including 1 and 3, 1, 3, not including 1 and 3, 1, 3, including 1 but not 3, 1, 3, including 3 but not 1. So these are the possible interval of convergence. For us to determine kung alin dyan yung interval of convergence natin, we have to check whether this infinite series converges when x is equal to 1 and when x is equal to 3. Let's do that. If x is equal to 1, this infinite series is just equal to this one. As you can see, this is an alternating series. So you might want to apply the alternating series. But for us to apply the alternating series, for us to apply the alternating series test, we have to check whether 1 over 2n minus 1 is positive for all n. However, when n is equal to 0, 1 over 2n minus 1 is equal to negative 1, which is negative. Therefore, we cannot apply alternating series test in this infinite series. But what we can do is to isolate the term where n is equal to 0. So what we can do in order for us to apply the alternating series test is to isolate the term when n is equal to 0. So when n is equal to 0, this term is negative 1. Thus, this infinite series is just equal to negative 1 plus this infinite series. So the term where n is equal to 0 is just negative 1. So these two are equal. Now, this is an alternating series. We now check if we can apply the alternating series in this one. So as you can see, 1 over 2n minus 1 is now positive for all n starting from 1. Therefore, we can apply the alternating series test. Let's call 1 over 2n minus 1 as c sub n. So we'll have the following. And let us try to apply the alternating series test in this infinite series. For us to apply the alternating series test, we have to verify two things. These two things are whether the sequence is ultimately decreasing and this limit is equal to 0. If ever these two things are true, then we say that this infinite series converges by the alternating series test. If that is the case, then if you apply any real number to that infinite series, the resulting infinite series will now be convergent also. Now, let us verify these two conditions. For us to verify whether this sequence is ultimately decreasing, let us let f of x be equal to 1 over 2x minus 1 for all x in the interval starting from 1. If that is the case, then f prime will be equal to negative of 2x minus 1 squared times 2. For all x in this interval, 1 over 2x minus 1 squared is always positive. Times negative 2, we have a negative number. So this is negative for all x in this interval. Thus, we say that C sub n is strictly decreasing. Since a sequence that is strictly decreasing is also ultimately decreasing, we say that this sequence is ultimately decreasing. Now for this one, we have to take the limit of C sub n as n goes to positive infinity. Your C sub n is 1 over 2n minus 1. So as you take the limit of n as n goes to positive infinity, this will just go to 0. So these two are satisfied. Thus, by alternating series test, we say that this alternating series converges. Now, if you add any real number to a convergent infinite series, we say that the resulting infinite series converges also. Thus, this infinite series converges. Thus, kasama yung 1 sa interval of convergence natin. So, kasama yung 1 sa interval of convergence natin. So, tatanggalin na natin ito possibility na ito, pati na rin ito. So, dalawa na lang yung possible interval of convergence natin. Let us consider the case where x is equal to 3. Let's see kung magiging convergent tayo infinite series natin o hindi. If x is equal to 3, then this infinite series is just equal to this one. As you can see, this is algebraic over algebraic. So, isa sa pinaka-recommended na test na pwede natin gamitin ay yung limit comparison test. So, kapag algebraic over algebraic, one of the best or one of the recommended tests to use is the limit comparison test. So, in order for you to use the limit comparison test, you have to check whether each term in this infinite series is greater than 0 or is positive. Notice that uh, for all values of n except 0, 1 over 2n minus 1 is positive. So when n is equal to 0, 1 over 2n minus 1 is negative 1, which is negative. So, ang gawin na lang natin, para ma-apply natin yung limit comparison test, i-isolate natin yung term where n is equal to 0. Thus, this infinite series is just equal to the sum of these two. Now, if you check, each term in this infinite series is now greater than 0, so you can apply LCD in this infinite series. Let's call each term in this infinite series b sub n. We have the following. So, ang ginawa lang natin, tinawag lang natin siya b sub n. For you to apply the limit comparison test, you have to look for another infinite series, say the infinite series of c sub n from 1 to positive infinity, where c sub n is greater than 0 for all n. Again, for us to use the limit comparison test, we have to look for another infinite series, say this infinite series where c sub n is positive for all n. Now, if you look at your infinite series, the degree of the denominator is 1, the degree of the numerator is 0, so you might want to take your c sub n to be 1 over n. Meron na dito 1 over n for your c sub n for all n. Again, the degree, quote unquote, of the numerator is 0, and the degree of the denominator is 1. So the difference in the degrees is 1. So you might want to take your c sub n to be 1 over n. If that is the case, then this infinite series diverges since it is a harmonic series. Moreover, if you try to apply the LCT, so applying LCT, you have to look for the limit of b sub n over c sub n as n goes to positive infinity. So this is just the limit of the product of these two. This is your b sub n, this is the reciprocal of c sub n. And we know that this limit is just 1, which is a positive number. Therefore, by LCT, kung anong nangyayari dito sa infinite series na ito, yun din yung mangyayari sa infinite series na to. Since we know that this infinite series diverges, yung infinite series na to, nagda-diverge din siya by the LCT. So by the limit comparison test, this infinite series diverges. So kung meron kang divergent na infinite series at nag-add ka ng kahit anong real number doon, magiging divergent din yung resulting infinite series. Thus, we say that this infinite series diverges also. So, hindi kasama yung 3 sa interval of convergence mo. So, tatanggalin natin itong possibility na ito. Thus, for our conclusion, we have the radius of convergence equal to 1 and the interval of convergence is given as this interval. This is our answer for number 2. For number 3, we have the following infinite series. So for us to determine the center of this power series, we have to factor out the numerical coefficient of x. Again, given this infinite series, if you want to look for the center of this infinite series, you might want to factor out the numerical coefficient of x. If you factor out -2, you'll get the following. And as you distribute the power n to -1, to 2, and to x minus 1/2, you'll get the following. Let's call each term in this infinite series a sub n. So let a sub n be equal to this one for all n. We wanted to apply the ratio test in this infinite series. So we have to check whether this infinite series has non-zero terms. Notice that this infinite series will have non-zero terms only when you consider values for x that is different from the center. So you exclude the center before applying the ratio test. So for all x that is different from the center, we take the limit of the absolute value of a sub n over a sub n. We take the limit of the absolute value of a sub n plus 1 over a sub n as n goes to positive infinity. As you replace values for a sub n plus 1 and a sub n, you'll get the following. So this is your a sub n plus 1, this is the reciprocal of a sub n. The absolute value of -1 raised to n plus 1 is just 1. So the absolute value of this will just be equal to 1. The absolute value of this will just be equal to 1. 2 raised to n plus 1 over 2 raised to n is just 2. The absolute value of 2 is itself, so you can factor out 2. X minus 1/2 raised to n plus 1 over x minus 1/2 raised to n is just x minus 1. So you can factor out the absolute value of x minus 1/2 since it is independent of n. So you can factor out 2 times the absolute value of x minus 1/2. What will be left to you is the limit of the absolute value of square root of n squared minus 9 over square root of n plus 1 squared minus 9. But notice that our n ranges from 4 to positive infinity. Therefore, the one inside is always positive for all n. Thus, its absolute value is itself. Thus, we will have the following. We know that this limit is just 1 or square root of 1, so that is just 1. So we'll have 2 absolute value of x minus 1/2. Thus, by the ratio test, this infinite series converges absolutely if this value is strictly less than 1. That is, when this absolute value is strictly less than 1/2. It is equivalent to say that this infinite series converges absolutely whenever x is greater than 0 but less than 1. By the ratio test also, we see that this infinite series diverges when x is less than 0 or when x is greater than 1. So far, what do we have? So far, we have the radius of convergence equal to 1/2 from this line. So from this line, we can say that the radius of convergence is 1/2. For the possible interval of convergence, we have the following from this line. Before proceeding to our next video, try on your own kung alin dito yung interval of convergence na hinahanap natin. So how do you do that? You check whether this infinite series is convergent or divergent whenever x is equal to 0 and whenever x is equal to 1. So bago nyo panoorin yung second video, itry nyo munang alamin kung alin ba dito yung interval of convergence na hinahanap natin. Okay? See you on our next video. Bye!